First, I will talk about a protostar is a collection of gas that collapsed on itself, or how it was what was before a star. It's essentially a large cloud of gas held together by gravity. Now, we will move on to a brown dwarf, and I will say that they were disappointment stars that aren't massive enough to sustain nuclear fusion. They are classified as substellar objects. They have a mass between the largest gas giant planets and the least massive stars, approximately 13 to 80 times of Jupiter. Now that we've talked about what's before a red dwarfs, which are in the main sequence shine very dimly and are barely massive enough to fuse hydrogen to helium, and how they don't go supernova, they actually just fizzle out. And not a single red dwarf has yet to die, because they burn their fuel so slow and can last close to 10 trillion year 1000 times the current age of the universe. The closest stars to Earth is a red dwarf called Barnard's star that is too dim to be seen without a telescope. Now, after a red dwarf has died, it can become a white dwarf when stars about as massive, or sometimes up to 8 times as massive as our sun. When they reach the end of their lifespan instead of going supernova, they shrink and become a white dwarf. These really old stars are very dense. If you took a teaspoon of a white dwarf star's matter on Earth, it would weigh just about as much as an elephant, being 5.5 tons. Now the larger of the star's supergiants. There are many different types of supergiants, like red supergiants or blue supergiant, even a yellow supergiant. One supergiant that comes right to my mind is called Betelgeuse. And no, not that fictional character, but anyways, the main question is, did Betelgeuse explode already? Because if you remember, Betelgeuse's great dimming in late 2019 and early 2020, as of now, it has been showing signs of going supernova pretty soon. And no, that doesn't mean in like the next week or anything. No, sorry to disappoint you, but it's probably going to be closer to about 100,000 years, but won't explode exactly in that time. It could be longer or sooner. Now let's go back in size a little bit and talk about the Sun and it being a main sequence star. Its lifespan is about 10 billion years, 7 times hotter than Barnard's star, and 300 times brighter, with twice its surface temperature, the brightest in the night sky is Sirius, which makes it shine 25 times brighter with a lifetime of 2.5 billion years. Now we go to the stronger of the stars, a neutron star, and how the physics can get a bit weird in their cores, because they are so condensed. In fact, they are so dense, if you put 1 teaspoon of a neutron star's core and dropped it on Earth, it would destroy the whole planet. Now, my favorite part, the largest stars of the known universe, hypergenic stars, like how some are so big they lose about 50% of the mass due to solar winds. The largest of all the known hypergiants is Stephenson to -18. Okay, we are at the end of our journey, a black dwarf star, a theoretical end of stellar evolution, because what they do is emit no heat or light. Black dwarfs would be a challenge to detect if they existed today. The reason I say that is because black dwarfs take quadrillions of years to form, and the age of the current universe is less than 14 billion years old. So unfortunately, the universe is still too young to have created any black dwarfs.
A photo of the moon I got through my binoculars on Friday, October 14th.